Checking your SWR, why this is important and how to take SWR readings. By Paul, Mike 0 Whiskey November Uniform or 26 Charlie Tango 730 if you catch me on 11 metres and PMR 446.
Hello, welcome back to the channel. It's Paul, Mike 0 Whiskey November Uniform, or if you catch me on 11 metres and PMR 446, it's 26 Charlie Tango 730. Okay, now I want to talk about something that is a very, very complex subject, but it's also very important to get the best out of your station and not damage your transmitter, whether it be a CB radio, which legally can put out 4 watts, or if you're a licensed amateur radio operator, it can be the radio itself, which if it's an HF set can be anything up to usually around about 100 watts. Or if you've got a linear amplifier, which could be anything. In the UK we're only allowed at full license level to use 400 watts, although in some countries you're allowed about a kilowatt or a kilowatt and a half. So obviously if things aren't matched properly with the antenna and the feed line, yeah, it's not going to end very well. So I'll explain. Okay. So what we have here, this is a very basic CB radio SWR meter. I've had this since I've had my Moonraker FA5000 CB radio, which is on the shelf just behind the camera. So it's not on camera at the moment, it's on a shelf. Basically this one probably isn't 100%, but so I've had it for so long, I've dropped it a couple of times as well, so the needle I don't think is in quite the right place, and also there's a red section at the end which is faded off. Now I'll explain what that is. So I'll read off this meter. Now the meter has a black section with 1, 1.5, 2 and 3. Everything after the 3 is red, and red always means bad. So I'll show you how to actually check for the measurements in a little while, but first I'll explain in the simplest terms possible, because this is a very complicated subject. So basically you've got your transmitter, be it a CB radio, it's my President Grant 2 and I'm not keen on causing damage to it, or any amateur radio gear. I've got one under here, QIT KT8900D. There's another CB that's just out, actually it might be in the camera, just down there, a TTI TCB 550, which I've nearly caused damage to because of high SWR. Okay, so you've got your antenna. Your antenna has to be a certain size. We'll call this the wavelength. That's generally what it is. Or half wavelength or quarter wavelength, basically. So for CB, which would be 11 meters roughly, we're looking at about roughly 5.5 meters for a half wave. Okay, so if the antenna would have something called a characteristic impedance of about 50 ohms. You'll probably see that referred to a lot on coaxial cables, and usually on the back of equipment if it's mentioned. Sometimes it isn't. It's sometimes mentioned in the instruction manual. So as long as everything matches, the antenna and the cable back up to the radio, that meter, when you measure for SWR, should not move. So, however, if there's something amiss somewhere, you've got like a short in the cable, or the antenna is the wrong size, then some of that power is going to be coming back down the cable and go back into your transmitter and ultimately stop the transmitting circuits from working properly by damaging or destroying them, unfortunately, which could get to be a very expensive repair. So best I'm going to explain. So I'm just going to find a piece of cable so I can actually demonstrate. It's just a short piece, not a long piece. This will do nicely, this patch cable. So we've got the cable here. So if the transmitter's perfectly matched, we'll go from this end all the way, transmitter and antenna, sorry, perfectly matched, will go from that end all the way out to the antenna, and all power would go out the antenna, nothing would come back the other way. Unfortunately, no antenna can perfectly match. So what would happen is a tiny amount of that power will come back. Tiny amount, not much. You'll have seen an example of this on my video that I did when I put the Stereo High Power 4000 onto my car. So I like to try and keep the SWR under 1.5, and there's a reason for that. Go back to the SWR meter here. This one has on the underneath percent reflected power. I'll bring it in. Not sure if you can actually see that. You probably can, you probably can't. So, percent reflected power, about 1.5, it says is about 4% back down the cable. In the grand scheme of things, that's probably going to not be too much. So I'm going to have to do some calculations here, and I don't actually have a calculator to hand, which is a bit annoying. Oh, actually, second thought, I do. I don't plan these things really, but I have my phone to hand, and that does have a calculator. So it's 4% of the power back down the cable. So see if I can do this right. So 4 take away 4%. Well, so 4% coming back would leave 3.84 watts, according to this. Unless I've got my maths wrong, which I probably have, so don't take that as gospel. Not all CBs are actually put out the 4 watts that they claim. Some put out about 3, 3.5. Some are that bad, they only put out about 2 and a bit. If measured on a properly calibrated test set, which I don't have, because I don't have that sort of equipment to hand right now, although I am going to need it in the future for selling on CB radios, because that's something I do plan to do eventually. Something I'm working on to make a tiny little bit of money and try and get more people interested in radio. So, and what I'll do in a little while is I'll demonstrate how to check for SWR. But I can't do it with an antenna because I don't actually have one connected up. The antenna that I want to use is in antenna corner. The video on that was the last video I did actually. So there's another type of SWR meter that I use for my VHF and UHF, and it's this, although you can probably get these for HF as well. These are a little harder to read, but you've got 2 pointers on this one. On this one, where the 2 pointers meet is what the actual SWR reading would be. So the lower the better, basically, and basically if both needles go all the way up to the top, then you kind of have a problem there. So causes of high SWR, not only is the antenna going to play a factor in that, but also the cable. So one way to check to make sure that you're not going to have an infinite SWR before you begin is to have one of these, the multimeter, and then what I'll demonstrate is how to check a cable for a short circuit. Now, or open circuit. I do have one that's open circuit, but it's not to hand at the moment. I'll probably put that to one side. So if I was to put my test leads, the meter's off at the moment, and put the meter to continuity, which I will do. If I put my test leads across the centre pin, I'm not sure if you can see this, let's bring that into the camera. The centre pin and the outer, so just hold that onto the outer and then put the other one onto the centre pin. That shouldn't beep. It's a bit difficult to do with one hand, and I don't have the best test leads. So I've got one test lead on there, one on there, nothing. So if I was to measure to the other end, should read continuity, which I can't get it to do because it's yeah, this is not really easy to do, but there we go. That's continuity from both outer points. Now if I was to do that to both inner points, the same thing should happen. That means there's continuity. However, if that was to happen between the centre and this, then you have a short. However, if there was no continuity between that end and that end, or that and that, then you have an open circuit, and both of those can lead to the SWR meter reading infinite. And that's definitely not good. That means if you've got to basically change a cable for a known good one, or chop off the plugs and put new plugs on it. And putting PL259 plugs on is not an easy task. So it can be done, but it's not the easiest job to do. So that's why I always recommend that whenever you actually do put those on by yourself, you actually do that check. Because otherwise you might have a problem. Because it only takes a tiny little whisker of the outer braid of the cable to touch the inner conductor to cause a short. Some antennas will read short, so if you do that while it's plugged into an antenna, then you probably will always get a short circuit, but your SWR should be fine. Another way of checking the SWR without actually transmitting is using an antenna analyser, and not all of us have that luxury. I'm unfortunately, at time of filming, one of the people that don't have that luxury despite having an amateur radio license. So I'm looking to get one, except funds are going to dictate that, obviously, as they do with this hobby. So what I'm going to do, I've turned on the Grant 2 over here, and if you just ignore that matcher on the top, we don't need that because that's just for making the best of a bad situation. I will bring that in just before I go on to the next part. So what this will do is, this goes in between the radio and the antenna, but needs a meter in line as well because it doesn't have one. This one's for CB. So you would adjust these knobs on the front until the SWR was as low as you could get it, basically. There are instructions on how to do this, supplied with these, and basically it's a case of turning one and then the other. Now this one didn't come with any English instructions, it came with French ones, so I had to actually have a nosy on the internet to find out actually how you did it. And I did. And I did get it to work with my Excalibur compact antenna, so that's why I've got it. Because that antenna does not tune no matter what I do. So, you know. So I'll bring the camera into the President Grant 2 and I will set it up with that cheap SWR meter. I'm not going to dig out the Capo or the Zetagi for this. They're still packed up from the other video. So I will do that next. I'll get that set up now. Okay, so we've got the President Grant 2 here. It's on the channel that I'd like to use, which is channel 11. Although at the moment I'm obviously not using the channel because there is no antenna connected. So first thing I need to do is you check on the lowest frequency of interest first. So I like to do it in FM mode because that's just how I am. Because that's how I've always done it. Can be done in AM. So obviously in America you're only allowed to use AM. But over here we can use FM, AM, upper sideband and lower sideband. So, and you wouldn't do this on sideband anyway, both upper and lower sideband, because there's no power until you start speaking. So we're on channel 1 of the mid blocks, CEPT, whatever you'd like to call it, which is 26965, which is the lowest frequency of interest. Over here we've got the SWR meter connected to a dummy load, specifically that one you can just see in the background there. Now, I've not used this SWR meter for a while, so this might not work. It did. Excellent. So what you need to do is, I'm going to have to try and do this one-handed because I'm actually holding the camera because I don't have a tripod to do this. So there's a knob on the end of there which is labelled calibrate. On this meter it's a bit full of dust and could use a spray. I'm just going to turn that up there. Yeah, this one's a bit fiddly. So it's very difficult to do because this is quite an old meter now. I'll just let go of the key again. So like I said, very difficult to do with this meter because this is a very old meter. This radio does have its own onboard SWR meter, but we're going to ignore that. There we go. So you turn that knob until it's on the set position, which is right at the far end of the red, so as long as that switch is in forward. So that's where that switch needs to be. So to find out what the SWR actually is, put that switch into reflected once you've obviously done the calibration and transmit. Now that needle did not move because of the dummy load, but normally at this point, just to prove I actually am transmitting, turn that. Yeah, actually am transmitting. So transmitting, nothing. Prove it again. Yeah, so actually I'm transmitting and getting a very low SWR because it's a dummy load and all the power's going into it. So at this point you'd take a pen and paper and write down where the needle actually stops. Now you can see why I don't actually use this SWR meter, because it's a very fiddly to actually calibrate it. Need some switch cleaner in the potentiometer. But this is just further demonstration of this. Right, so what I like to do is like to look at the middle channel as well as the highest channel. So that would be channel 40, which I've now changed to on the CEPT, or you could do it on channel 1 on the UK block of frequencies, because that's around about the middle still. So you do the same again, start again with the forward, check where that needle stops. Again, it's very fiddly with this meter, but you know. There we go. There, so you put that on the set, on forward, and then again, reflected. Again, that's going to show nothing. So if you were to do this for just the EU band or the UK band, it would be channel 1, channel 40, or channel 1, 20 and 40, or you could just do it on channel 20, which is for lowest possible on channel 20, so it's slightly higher at the outer edges. But I'm looking to check across the mid, but I always look to check across the bottom, middle and top. So we're now on channel 40 there, so I now need to be on channel 40 on the UK block, which I would have done even if I didn't do channel 40 on. And that's my highest frequency of interest, which is 2799125. So back to the forward again. Now that's dropped a little bit, so that means I'm going to have to adjust that. Again, it's very fiddly on this meter, like I said. This is just for demonstration, so there we go. And again, there is no needle deflection. None at all. So I'll go through that process again. So if you just want to do it on the UK 40, check there first, put that to forward, turn that, I'll actually go through it properly. So flick that across, turn that to forward, see if that's on the set mark. It actually is, nothing I need to do here. And then check again by putting it into reflected. Yeah, so you do that on 1 and 40 or 120 and 40 and make a note of the readings. Now here's where you can work out if your antenna is too long or too short. So I'm just trying to remember which way around it is now. So if it's higher on the top end of the band than it is on the bottom end of the band, then the antenna is too long, needs to be shortened. But if it's higher the other way around, it means the antenna is too short, needs to be lengthened. So in order to do that, there would be an adjustment on the antenna. That could be grub screws, or some antennas have what's known as dialer match. I think they're mostly Solarcon antennas. Some antennas have a adjustable whip on them at the top, which hence the grub screws, or the whole whip's adjustable from the bottom of the antenna, or it could be an adjustment on the loading coil itself. So should look to try and get it 1.5 or below, as long as it's somewhere in the region of 1.5 or below. Because obviously if it's above that, then more power's coming back down and not as much is coming out of the antenna, and you won't get as far. Especially important on CB because it's only 4 watts. So there you have it, and as I say, this has got its own built-in SWR meter, so I don't know how accurate it is, but it seems to tally up. So that's the SWR meter in the President Grant 2. If I was to disconnect something there, that would shoot all the way up. So you should be able to, I'll just zoom in on the display of the Grant 2 a little bit there for you. So you can see the bottom level says SWR, and just that first bar lights up. So it's 1.5, 2, 3, and nothing after that really. Dragon, start button I want. Yeah, because it'll take the S meter out of RF power mode, and if you press that button there. A lot of higher end radios do have the built-in SWR meter. The President Grant 2 was certainly one of them when it was made and sold. I think it's out of production now, which is a shame. It's actually kind of a good radio, which is why I wasn't keen on blowing it up. So these SWR meters aren't exactly expensive, usually around about, well, depends on where you get one from. Now, getting a brand new one, you won't have issues with the potentiometer or anything, because it'll be nice and clean and just come out of a box. Usually around about about somewhere between £10 and £13 for the most basic one for CB. If you're an amateur radio operator, you'll obviously want to spend a little bit more on one that can do a fair few more frequencies. So a dummy load's a good way of checking to make sure that the radio is working if you suspect you may have damage to the radio through high SWR. Now the damage is done to transistors inside the radio that won't tolerate the power going back into them for very long anyway. So that's why they always say in the instruction manuals of these things, don't transmit without an antenna. It's very important. So why is SWR checking important? So that your radio transmits at its best and you don't end up damaging it and rendering it unable to transmit. It's very important in anything with high power applications, so amateur radio operators, broadcast transmitters, anything like that transmit at high powers, because then it can get really expensive, unfortunately. But a CB radio is at 4 watts. If it's a high-end CB radio, you do want to make sure the SWR is matched. Now, if you like to be slightly naughty on 11 meters and run a linear amplifier, you've got to also make sure that SWR is as low as possible, because linear amplifiers only have a certain tolerance before they're damaged or rendered inoperable because of high SWR. I'm obviously not going to cover that too much, because linear amplifiers on CB are a big no-no. I know people use them, and I do actually own one, but I do not use it on 11 meters. I've only ever connected it up to put it into a dummy load, and once I can ascertain that the thing can generate a clean output, I will probably use it on 10 meters with my CRT SS9900, simply by running the SS9900 at a low power and putting the power up using linear amplifier. It's about 35 watts, the one I've got. It came with some CB stuff, so I'm guessing the previous owner had used it on CB, and they weren't that clued up on electrical safety either, because the fuse was wrapped in foil. But you know, so there you have it. SWR, very important. Make sure everything's good, below 1.5 particular, and you should be fine. So I will probably cover this subject again at some point. I've tried to simplify it. I mean, this is as simple as I can get it. I mean, I think other people could simplify it better than me. And obviously the SWR meter I was using for the demonstration was not the best in the world, because it's got a dirty potentiometer. So my advice is, if you do have an SWR meter that's got a calibration control that does that, just get some switch cleaner in there. If you can get hold of any, you should be able to get hold of that from any electronic supplier on the internet, or even Amazon. Servicol Super 10, that would do. That's a very prominent brand. I'm not advertising Servicol, I'm not sponsored by them, I'm just saying that's a very prominent brand, and that's the sort of stuff I would actually use. I don't have any at the moment, which I really should. So I will probably cover this subject again at some point, and once I've got the boomerang up, I will show you what that's reading at. So, well, thanks for watching, really. So this is Paul, Mike 0, Whiskey November Uniform, or 26 Charlie Tango 730 if you catch me on 11 meters and PMR 446. And just a heads up, I've already alluded to this a couple of times, I shall be in attendance at the Blackpool rally at the Norbreck Castle Hotel at the end of April. So if you see me there, just say hi. I'll probably mention this again before the event. So 7-3 for now.
Don't forget, you can subscribe to this channel and ring the bell to be notified of new videos as I upload them. 73 is from Paul, Mike 0 Whiskey November Uniform, or 26 Charlie Tango 730 on 11 meters and PMR 446.